Hi everyone, welcome back to the channel. I'm the GCSE Science teacher. In today's video, we're going to be learning about infrared radiation and absorption, specifically the required practical that you need to know for GCSE Physics. I hope you guys do find this video helpful. If you do, please do let me know by liking the video. You can also share this with someone else so they learn more science as well. And if you haven't already and you'd like to, please do subscribe. It's absolutely free. It'd be great to have you as part of our community. And thank you so much to everyone who already has. I really do appreciate your support. So let's get started. Let's talk about the aim of this practical. What do you actually need to know? What do you need to do? And why are you doing it? So the aim is to investigate how the amount of infrared radiation absorbed or radiated by a surface depends on the nature of that surface. I'll show you the method. I'll show you what kind of apparatus or equipment that you need as well. But how do we actually do this? Well, we're going to literally measure and record the infrared radiation coming off the surface using a specific device. We can use a thermometer as well if we wanted to, but there are specific devices that detect infrared radiation. So I'll show you that in the equipment setup. Just as a bit of background as well, just remember we talked about electromagnetic waves or those EM waves in a previous video. I'll link it for you in case you missed it. But infrared radiation is very close to the visible light spectrum, but we can't see this. We can only detect it. It's to do with like thermal imaging and things like this. So it's the heat that is released off objects, and all objects are able to emit thermal infrared radiation. It has a slightly larger wavelength than visible light, for example, and you can see that in the spectrum here. So just putting into context where this is in the EM spectrum itself. So there are a few variations to this practical, and you can change some of the apparatus, which I'm going to show you depending on what you have available, etc. But some of the key ones include the Leslie cube itself. So this is just a 3D cube that has 4 different surfaces on. So a shiny metal, a shiny black, a matte black, and a matte white surface. You could, however, swap this out for boiling tubes and just change the surfaces around the boiling tube itself. So have some foil, for example, some black card, some white card, have shiny surfaces, that kind of thing could be a good alternative if you don't have a Leslie cube. The Leslie cube is really good though because it's set up for this, and each of the sides are equal in terms of their area. The volume as well will be fixed, which is great because what you're going to do is you're going to fill the Leslie cube with boiled water, and it's a fixed volume in there. So you are controlling the amount of water and the temperature as well because you've boiled it to 100 degrees. So this is a really good option as the first piece of equipment that you need. We also have a heat-proof mat just to protect any of the surfaces that we're using from the heat that we have in the Leslie cube. An infrared detector can be used to detect any of the infrared emissions that are coming off each surface. However, you could, like I said, use a digital thermometer to do this as well. That way you can get temperature results. I have some data which I'll show you using that method as well, but either works really well. The kettle that you need to boil the water that you fill the Leslie cube with. You'll also need to use a ruler so you maintain the same distance. That's a control variable in this case. And also just some tape just to ensure that you're not moving that ruler around. So it's a nice specific space and you can keep that control variable really strict because obviously the distance you have between the detector or the thermometer and the Leslie cube and the surface, you don't want it to vary too much because you want to maintain it and make it comparable. Also, just in terms of safety, feel free to use goggles. You can also use a heat-proof pair of gloves to protect your hands as you move the Leslie cube around. That would be really wise to do. And other than that, you will only need a stopwatch to make sure that you are making the amount of time between your readings accurate, and also to allow the Leslie cube to acclimatize to the new temperature change. Something else you could do if you wanted to look at more of the absorption of infrared, because on this particular video, I've focused mainly on the emission or how those objects emit that infrared radiation and we're detecting that emission. You could also look at how infrared is absorbed by these surfaces. So what you could do is instead of detecting the infrared, you could actually have an infrared source and heat up an object and see how the temperature increases. So that's something else you could do to change this practical up and see a different version of this. That's something you could also investigate. So hopefully that gives you a bit more of an understanding. If you do have any questions though about anything I've said, please feel free to comment down below. So, in terms of the method itself, the first thing you want to do is fill the Leslie cube with boiled water and place on a heatproof mat, closing the lid afterwards. Because the Leslie cube is a given set volume, you don't need to be too specific in how much water to fill it to. Just make sure it's fully filled. If you want to be super accurate and you want that control variable to be perfect, you can obviously pour out the boiled water into a measuring cylinder to ensure the same volume. Just be very careful, obviously, as it is boiled water. At this point as well, if you're touching the Leslie cube that's filled with hot boiled water, it would be worth using those heat proof gloves as well. You can use goggles, like I said, it's up to you. I always recommend goggles. If in doubt, just go with goggles. And then what you want to do is you want to use your stopwatch, press the minute timer, and leave the Leslie cube to heat up all those surfaces nice and equally for around a minute. You can leave it for longer, but remember not to leave it too long because we don't want the temperature to decrease really lower than that 100 degrees Celsius mark. After this, you want to place the Leslie cube, the first side of the Leslie cube, whichever one you choose first, and you want to make sure that it is at a set distance from either your digital thermometer or your infrared detector. And you do this by using a set measurement. So, for example, using a ruler. You can also use some tape as well at this point, just to make sure that there is like a start line, a finish line, if you will. So there's a definite set amount as you move that Leslie cube, because you don't want to move it as you turn it. You don't want to move it too far away, and therefore your accurate results aren't as good. Okay, so once you've got that set up, you want to detect the change in temperature or the infrared emissions, and you want to basically record this every 30 seconds for 5 minutes for one of the sides, and do the same for each of those sides again, and repeat this to calculate the mean average. You want to also, like I said, when you're recording this, put this into a table. It's worth drawing that table prior to collecting the results, just so you can pop the results directly into it. And that way it just makes it a lot easier. The mean result can be used to plot a temperature against time graph if you're looking at the temperature change. Again, this depends on what type of graph you want to do. I'll show you a line graph that shows this, or you could also use categorical data if you wanted to just see the best surface. For example, you could just have like a bar chart where you have each of the surfaces and which one has the best emission rate, or the one that emits the most or the least infrared. It is completely up to you how you wish to go about it, but that is something that you could do depending on the results you want to look at. It definitely wouldn't be one of my required practical videos if I missed out the variables. It's really important to mention this because at GCSE there are so many marks worth for just knowing what variables are, how to apply this idea of variables to certain situations, whether it's biology, chemistry, or physics. The idea is the same thing. So I want to just mention this at this point so we can then apply it to this practical as well. So what is a variable? It's something that you're going to change, it's something that you're going to measure, or it's something that you're going to keep the same. And this is to conduct a really accurate set of experiments and also make sure that your results are reliable as well. In science, obviously, if someone does an experiment, someone else will follow the method to ensure that they get the same results, or if they don't, they can have that discussion. And it's a really great way to drive scientific theories and ideas forward. So doing really strong methods and having variables ensures that. So how do we remember what variables are and what do we know about them? So there are 3 variables you should know: independent, dependent, and also control variables. The way I remember this and help my students remember this is SID-SAM. So it stands for C for control, S for same. So a control variable is something you keep the same, and you do this because it allows you to compare results across different sets of data. So that's a really great and key idea for you to know. We don't want to at GCSE say that controls are done to make the results fair or to allow for a fair test. That's very Key Stage 3. We want to increase our understanding to Key Stage 4 and say that it's to allow for comparable results. So in this case, what are we keeping the same? Well, we're keeping the volume of water the same. We're keeping the temperature the same. We're keeping the area of the surface the same. We're keeping the distance from the either the digital thermometer or the infrared detector the same. There are lots of things that we are keeping the same to allow for that comparable result. The next variable is represented by I. So independent variable stands for what we alter. So A for alter, what we change in this experiment. So if we look back to our aim, we can see that we're looking to investigate the different surfaces and how much they emit infrared radiation or absorb it. And therefore, if we're looking to investigate that, then we're also looking to change it. So the surfaces that we are investigating are what we're changing. They are our independent variable. So maybe the surface color or the surface texture or something like this would be an appropriate answer there. And then the last variable we're going to look into is the dependent variable. So D stands for dependent, M stands for measure. What are we measuring? Well, depending on what type of version of this practical you want to do, you're either measuring the temperature change over time or you're measuring the infrared detector results over time. So you can use like a digital thermometer or an infrared detector. It depends on what you'd like to do and how you want to measure your results. But that's essentially what we are looking to do. Like I said, with knowing your variables this way, you can apply it to any unknown practical, especially those of you who are doing triple science. That way you can really apply your knowledge and get those higher level answer grades as well. So here are some of the results just to help you guys out. We have temperature in degrees Celsius on the y-axis over the time. And as you can see, all of them started at 100 degrees Celsius. And over time, of course, the temperature started to decrease, but we can see that the emission rate for each of those different surfaces, the matte black surface is the one that has really the highest emission. That one definitely is good at absorbing as well. Usually we find that to be the case. As you can see, shiny metal in this one as having a very small gradual decrease in temperature. And again, you could use this data to compare those different surfaces. It's really nice to do this if you have a big class and each class has each of their data and we can all compare it together. That way you can write a nice conclusion for this particular practical. And that's it from me today. I've been the GCSE science teacher and you have been curious. If you did enjoy this video, please feel free to like it, share it with someone else, and do subscribe if you haven't already. Click the bell so you get notified. I do upload every week on a Sunday at 12 o'clock UK time. So if you would like to make the most of these free revision sessions, feel free to definitely subscribe. And thank you so much if you have already. I will link some videos for you guys if you want some more revision from me. I also have an Instagram and TikTok. Everything is at the GCSE Science Teacher. Have a fantastic day and I will catch you in the next one. Take care.